Hey guys, I am going to make a video of this 4.2 day 3. One, because it's hard. Word problems are always confusing to people. So I want you to have a chance to look at it again. And two, I didn't see one in Schoology that would help you figure this out. So what's going to happen here is we're going to be doing word problems. The key is to kind of think through like the key features of parabolas. They're almost always going to talk about what's the max, what's the min, what's the highest, what's the lowest. So they're going to be asking, they're just taking parabolas and putting them in real life situations. But in those situations, they're going to maybe ask like, how far did it, go before it landed? Well, that's an x-intercept. We only know how to do that if it's in intercept form. Might ask about the max. Well, the max or min, whatever they ask about, is simply the vertex. And we know how to find the vertex in all the different types. So what you do is you read the problem and you decide what form that equation is in. And then you go from there. So you have to just not let it freak you out. So if I read this first problem, the path of a place kick in a football game can be modeled by this function. Okay, there are not parentheses. So that, to me, tells me this is standard form. Now, it might look kind of weird because it only has two parts, but that is just telling you that it's the same as having y equals negative 0.026 x squared. So this is my a value. Plus 1.69x, that's my b value, and then plus 0, so that's my c value. Okay, so it says to sketch the graph. All right, well, what kinds of things do we need when we're sketching it? We need the vertex. So to get the x part of the vertex, I'm going to go ahead and I'm going to do opposite of b over to a since it is in standard form. So I'm going to have the opposite of 1.69 over 2 times negative 0.026. So this is definitely a calculator thing. When you go to do the bottom of this one, you actually are going to want to make sure that your calculator knows that it's negative 1.69 divided by this entire thing. So 2 times negative 0.026. So the parentheses are showing it that it needs to divide by everything. Taking a little calculator break here to do that math. I am getting 32.5. That is going to be the x coordinate of my vertex. The y coordinate of my vertex is going to have me plugging that in. So I have to go back to my equation, and I'm going to use my calculator because these numbers are big and intimidating. I put in my 32.5 squared. I put in my b value. There's a decimal there. That's terrible. And then I put my 32.5, and then my c value is 0, so I don't really need to do that. So I'm going to take a second here to put this into my calculator carefully with parentheses and all. Don't forget the square. That's a popular thing to forget, but it's super important. Okay, so I am getting 27.5 basically. Okay, so the vertex of this, and keep in mind that this opens down, so the vertex is going to be a high point. The vertex is 32.5 and then has a y coordinate of 27.5. So this is representing like the ground, so like time going forward or distance going forward, and this is representing the height. So I have to make 32 is, if this is my path, like this is what a football would do, it would go up and come back down. That's 32.5, which means that all the way across, since that's in the middle, would be twice as big as that. So if I take 32.5 and double it, I'm looking at 65 for it to get all the way over here. So if this has to be 65, what do I have to be at? 510? Is this going to work? 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Yeah, okay. So this is going by fives. I don't know why I wrote 5 squared. Who knows? So that means my axis of symmetry, which is going to always go through this X part of my vertex, is at 32.5. So if this was 30 and this is 40, this is 35. So 32.5 is in between that. That is the halfway point. If it's halfway, we decided that it'll land after 65 feet. So that means here at 65, it comes back down to the ground. My y-intercept, keep in mind your y-intercept in this standard form is always 0 and then the C value, but our C value is also 0. But that makes sense to me. The football started on the ground, got kicked up, came back down, and then hit the ground at 65 feet out. And 32.5 is the max height. And it said the max height's 27.5. So up the side, we have to go to at least 27.5. So 5, 10, 15, 20, 25, 30. Certainly I could have spread that out more, but you can do whatever you want. So 27.5 would it be about here. So this football goes up, hits that peak, and then comes back down. That is the path of that football. Okay. So it's asking what the max height is. Whenever it's asking you something like that, it's asking for part of the vertex. So what we learned about our vertex is the football will have gone forward 32.5, and at the highest point, it will be up 27.5. So when it asks what is the football's max height, it's asking for V sub y, and that is 27.5 feet high. That's how high it goes. That's the max value. How far was it kicked? It's asking total, and we already talked about that. Since this was the halfway point where it got to the highest, it has to go up, come back down. We took our 32.5, that was the middle because of our X part of the vertex, and we doubled it. So it was 65 feet. That's how far the ball goes. It goes up, comes back down. Halfway is 32.5. So the other half is 32.5. And when you put those together, it's that full 65. So you're not doing any different math. The key is to figure out what kind of formula it is. It's a standard form. And then just think about what they're asking. Don't make it harder than it is. Here, blah, 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 blah. I always look at the equation first. And actually, this one always bothers me because this should not be negative. Because if you look at this picture, the parabola is obviously not opening down. So that should be a positive. That bugs me every time I see this worksheet. So the Tacoma Narrows Bridge in Washington has 2 support towers. Here and here. That rise 370 feet above the roadway and are connected by suspension cables as shown. Each cable length can be modeled by the function given, where x and c of x are measured in feet. So understand what that means. X means how far out you've gone, like your distance. And then anytime here, C of X simply means the cable length at that X value. So if I keep going over to here and then up, this is going to be the cable's length at this X value. So we don't need to figure out the formula. They gave it to us. What we need to do is decide which form it's in. We have parentheses squared, so this is in vertex form. So you're using the middle column of your chart. What is it going to ask? It says, what is the height, so that's talking about the y, of the shortest cable? Okay, well the shortest cable's right here in the middle where it dips down. Not surprisingly, that is talking about this vertex, because if I drew this parabola, zoom, 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 this is going to be where it turns around. That's my vertex. So it happens like in the middle of the bridge, which is going to be my Vx. But then how high it goes, how long that cable is my VY. So this is asking you for the Y part of the vertex. This is vertex form. So there's no math involved in finding the vertex. We use the opposite of this number, so 1400, and then we use this number as it appears. What that tells me over in my picture is that I go over 1400 feet to get to the middle, and then that cable is the shortest one at 27 feet. That's how I get to that spot. So the height of the shortest cable is the VY. That's going to be 27 feet. And keep in mind with the word problem, you want to label properly because 27 feet, inches, miles are all very different. Now think about what this is asking, the distance between the two towers. Okay, here's the tower and here's the tower. We're looking for this. We know how far it is to here, which happens to be the middle. It's 1400. So if it's 1400 on the left, it's 1400 on the right. So my total will be 2800 feet wide. So that one you got to kind of think through, very similar to what we did with the football up above. The vertex is in the middle. So if you want to know the total length, you can find that by taking your middle value and doubling it. Okay, so we had one that was standard form, we've had one that's vertex form, and you will probably not be surprised that the next one is going to be an intercept form. Now this is by far the trickiest one to set up because you're not given the equation, you actually have to create it, which is the part of word problems that most humans despise. So all of these are going to be the same type of problem. We call them a revenue problem. Revenue is how much money you're making. And revenue always equals the price of something times the number that you sell. So if you're selling something for $5, the amount of money you make is $5 times however many you sell. So if you sell 10, 5 times 10, you made $50, and so on. So this is always kind of going to be the case. Your revenue, meaning the money you took in, is what is the price of each thing, oopsies, and how many did you sell? How much money times how many. So when you set this up, all of these are going to have a revenue equals one set of parentheses to represent your price, one set of parentheses to kind of represent the number that are getting sold. So what you want to do is build an equation. At Target, a certain toy sells for $20. Okay, that is the starting value of money. So that goes in my money part. About 300 of them are sold. That's the number that are sold. So if you sell 300 for $20, you're going to make $6,000. But they're going to make a change in all of these problems. A business analyst predicts that for every $5 increase in price, okay, think about that. First of all, it has to go into my price factor. It has to increase by $5 every time you make a price increase, because it says business analyst predicts that for every $5 increase in price. So that's how I set this up. These values are going to be my initial price and the initial number I sold. This second number is going to be how much I'm going to change the price by, and then how much that's going to change the number sold. So as I keep reading, it says for every $5 increase in price, there will be 30 fewer sales. So fewer is going to mean that I need to subtract. So now that's pretty hard to read because I put highlighting and everything. So what you're saying is I'm writing the exact same thing. You're saying you started at $20 and you're adding an increased price of 5 some unknown amount of time. My X is representing the number of price changes. I did not leave enough space there. Let's try that again. So X is going to be the number of price changes. How many price changes of $5 each can you make? Then that second factor is talking about how many you sold. You initially sold 300, but those sales will go down by 30 for every price change that you make. If you're increasing, these will always be opposite, you guys, because if you're adding to the price, you will sell less. If it was decreasing the price, then you'll sell more. So one of those is always going to be adding and one of those is always going to be subtracting. Okay, so this is our intercept equation that we have to use. So now it says determine how many price changes, so that's asking you to find X, that would maximize the revenue. Okay, so we're looking again at finding the vertex. So this one's kind of tricky, again, because to do the vertex here, we need the 0 from this one and the 0 from this one. But it's not as easy as eyeballing it, because we have to actually calculate what makes 20 plus 5x equal 0. I'm going to put that over here. So I would take away the 20 to the other side, and I'd have negative 20 equals 5x. Dividing by 5, it would be a negative 4. But that doesn't really make sense because you're talking about the number of price changes, and you can't make negative 4 price changes. So this one actually doesn't give us any answers. Okay, so over here, I have what would make 300 minus 30x equal 0. So I would move the 300 over by subtraction. I would get negative 30x equals negative 300. Dividing by negative 30, I find out that it would be 10 price changes. 10 price changes makes so much more sense than negative 4 price changes. Okay, so I need to find, hang on, I'm gonna, my X coordinate for my vertex, because it says how many price changes. So what I need to do, remember, these are my zeros. I'm going to take my first 0 plus 10, which is my second 0, and divide it in half. Okie doke. So that gives me 6 over 2, so 3 price changes. So you want to do the best business and maximize your sales and money. You make 3 price changes. Probably shouldn't have crossed this off because I don't need to use the negative 4 here. I use it in my formula, which doesn't generate a negative number up here. I got 3. There's not enough room for me to do all this work. So it says determine how many price changes. The answer is 3. That's asking for the X part of the vertex. Okay, then find the new price and the projected revenue. Alrighty, well, the new price, keeping in mind that our price part was this. It was $20, and you're going to do a price change of 5, and we just decided we were going to do 3 of them. So that would turn into 20 plus 15. So the ideal price for you to maximize your profit is going to be $35. That's the new price. So what's my projected revenue? Well, my revenue equation was this one up here. I'm going to have 20 plus 5x, which I just figured out was 35. And if that's confusing, you can just start with the whole formula. Like if you don't put that all together that they just asked you that, you would just go to your formula, 20 plus 5 times the 3 that you just got as the right number of price changes to maximize. and then 300 minus 30 times the 3 price changes. And you can just get that whole thing into your calculator. And when you do, you should get 7,350. So without question, the revenue problems are significantly harder just because there's more to do, but they're always going to be set up the same. So kind of walk yourself through what information is about money, what information is about the number of items, and sort through it in that manner. Hopefully that helps and gives you a little more time to process that type of word problem. And then I will make a video of the word problem side of the worksheet as well, the review worksheet. Bye.